Good morning, everybody. We're going to do a little bit more multiplication, division, equation solving, but this time we're going to start including some decimals and fractions. So I have some reminders on some of the rules we keep in mind when working with fractions. Don't need to write these down. These should already be in your notes, so make sure they are, please. So when we're multiplying fractions, remember multiplying fractions is easier than most people remember. You multiply straight across and simplify. And to make it even easier, to keep your number smaller, we can simplify before we multiply. Remember, when we're doing that, we're just looking for things on the top and bottom that have a common factor we can reduce. So we'll see that happen as we go through our examples today. Okay, for dividing fractions, well, if you can multiply fractions, you can divide fractions, because remember, dividing is just multiplying by the reciprocal. Right? So keep, change, flip are the words that we use to remember that. So we're going to just flip the second one, and then same thing when we were multiplying. Okay. The other thing to remember about multiplying and dividing fractions, we cannot do it with mixed numbers. Okay, we can add and subtract by keeping them mixed numbers, but if we're multiplying or dividing, we need to turn them into improper fractions. Now, that's not to say it's impossible to multiply fractions as mixed numbers, but it's a little bit more involved than we've learned how to do. So something you'll be able to do later when you learn how to do that. But for now, it's definitely going to be easier to turn them to improper fractions. So let's look at a couple examples. So I have negative 3/5 x. Remember, this means negative 3/5 times x equals negative 10. Okay, so I'm going to do the train tracks as always. That's always the first thing I do. Okay, remember, I'm going to undo by using the inverse operation. Because these are being multiplied, the opposite of that is dividing. Okay, so I'm trying to get the x by itself. That's my goal, because I want x equals something, so I know what x equals. So since x was multiplied by negative 3/5, I have to undo that by dividing by negative 3/5. Okay, when I do that to both sides, that cancels out and leaves x by itself. Okay, and now we get to keep, change, flip. I also got to remember my positive negative rules. I have a negative divided by a negative. Hopefully remember that is a positive. Okay? So the two negatives cancel out. So I'm going to do 10 divided by this. All right, 10 is 10 over 1. Keep that 10. Change it to multiplication and flip 3/5 to 5/3. Okay. I like to see if there's anything I can cancel out. The 5 and 10 are tempting. They both have a 5, but I can't reduce those because they're both on the top. Remember, anytime you're reducing, you have to find a common factor of one thing on top and one thing on bottom. Okay, it can be in the same fraction, or it can be in different fractions, but it's got to be top and bottom. So I just got to multiply these out. 10 times 5 is 50. 1 times 3 is 3. Okay, to simplify that further, I notice this fraction is improper. I want to make it a mixed number. So how many times does 3 go into 50? Okay, maybe you know that, maybe you don't. If not, we can just pull that off to the side. How many times does 3 go into 50? Well, it goes into 5 once. Bring down the 0. It goes into 26 times. Now, normally we don't just stop with the remainder, but in this case, when I'm making it a mixed number, how many times it goes in and the remainder is what I'm interested in. So 3 goes into 50 16 times with 2 left over. So 16 2/3 is my answer. Okay, if I think about plugging that in, again, I don't need to do the whole multiplication, but I want to make sure it makes sense. So I'm taking 16 2/3 and multiply it by negative 3/5. Well, it's a positive and a negative, so I know a negative answer makes sense. And also multiplying it by 3/5 will make the number smaller, because 3/5 is less than 1. Okay, so 10 being about 3/5 of 16 2/3 makes sense. Okay, so it seems like a reasonable answer to be there. All right, let's look at another one. All right, so 8/11 x equals 9. Again, I'm going to do train tracks. Do the inverse operation. It's being multiplied by 8/11, so I'm going to divide by 8/11 on both sides. Okay, so I do 9 divided by 8/11, which is 9 times 11/8 to keep, change, flip. Okay, I don't have anything I can divide out on top and bottom. So I'm just going to multiply. 9 times 11 is 99. 1 times 8 is 8. Okay. So 99/8. Okay, to simplify this, I want to see how many times does 8 go into 99. Looks like it's 12 times with 3 left over. So that is 12 and 3/8. Okay, so if I think about plugging that in, this again is less than 1. So if I multiply 12 and 3/8 by something less than 1, I'll get something less than 12 and 3/8. 9 seems to be about right. All right. Now you may be noticing, I'm going to point this out. What we ended up doing when we went through this process is we ended up taking 9 and multiplying by 11/8. And because of the keep, change, flip idea, that's kind of how this is always going to work. You might end up just going straight to multiplying both sides by the reciprocal. And let's see why that works. So if I just start off by multiplying both sides by 11/8, because remember, I can do anything I want to both sides as long as I do it to both sides. If I think about this, well, we've already talked about what happens when you multiply a reciprocal by itself, but a number by its reciprocal. 11/8 times 8/11, because everything would cancel, is just 1. Okay, and 1 times x is x. So that's kind of the shortcut what we end up doing. Now, you don't need to use that shortcut. You can think about dividing and flip. That's fine. But if you notice that pattern developing, that's why. All right, let's do another one. Doing my train tracks as always. Again, h is being multiplied by something, so I'm going to divide by that fraction. Okay. Once I do that, I got a positive divided by a negative, so I know my answer will be negative. That goes away, so I get h equals, okay. So I'm dividing by negative 7/20, which means I'm multiplying by negative 20/7. Now, don't get too wrapped up in whether the negative is at the top number or the bottom number. It doesn't really matter. Just think of the whole fraction as being a negative. So you don't need to tie it to the top or bottom. All right, so if I multiply this out, man, this would be really nice canceling, and so would this. But I can't because these are both on top. These are both on bottom. Okay, so I don't have any common factor on top and bottom. So I got to multiply out. So we got 10 times 20 is 200. 21 times 7 is 147. Okay, so I know 147 goes into 200 one time with 53 left over. So negative 1, 53 200ths. Okay, that was kind of tempting to try to cancel stuff, but we can't do it there. Only if there was one thing on top, one thing on bottom that had a common factor. All right. Let's go on to look at some decimals. Oh, no, sorry, we got a couple more fraction ones. So go ahead and I'm going to pause the video here. Why don't you give it a try, see what you come up with. All right, welcome back. So hopefully these are the answers we got. For the first one, it's negative 15. We divide both sides by 4/5, which is the same as multiplying by 5/4. Negative 12 times positive 5/4 is negative 15. Okay, here's one where we were able to cancel. Right, the 12 and the 4, because we have one on top, one on bottom, we were able to divide those by 4, making that a 1 and a 3. So 3 times 5 is 15. Only one's on the bottom, so it's 15. And negative, because we're doing a negative divided by a positive. Okay, for this one, we multiplied by 7/6 to get rid of this 6/7. So 5/1 times 7/6. Nothing to reduce here. It's 35/6, which is 5 and 5/6. And again, that's a negative divided by a positive, which is negative. So negative 5 and 5 6. Okay. All right, again, if you think about plugging this in, we have a positive times a negative, which would give us a negative. Okay, and 6/7 is just a little less than 1. So if we multiply this by a number a little less than 1, it should get a little bit smaller. Right? And 5 is just a little bit smaller than 5 and 5 6. All right, so let's take a look at multiplying and dividing decimals real quick. Remember when you're multiplying decimals, you don't need to line up the decimal points. You're just going to multiply the numbers as if the decimals weren't there. Count the numbers behind the decimal and move it to have the same number of digits behind the decimal in the answer as in the problem. Again, this should already be in your notes, so you don't need to write it down again, assuming it's already there. For long division, it's okay to have a decimal here, but we don't want a decimal here. So if we do have a decimal and the number outside, we just have to move it, and then move the decimal the exact same number of places in this number as well. Okay, so if this is already a whole number outside, you don't need to move the decimal at all. All right, so let's do a couple examples. Train tracks always. Okay, A is being multiplied by 7.2. I can do that by dividing by 7.2. Okay. I have a negative divided by a positive. I know my answer will be negative. And I got 3.6 divided by 7.2. Okay, so if I go to divide that, I do have a decimal outside. That means I need to move the decimal point over 1 and move it over 1 here as well. Okay, so the decimal is now after the 6. 72 does not go into 36, so I have to add a 0. It does go into 360. Okay. It might take a little bit of trial and error, but it goes in exactly 5 times. Right? 72 times 5 is 360. Okay, so 5 times that is 360, nothing left over. Okay, so 0.5, so negative 0.5 is my answer for A. All right. Let's try a couple of these. Again, I have the x on the other side. It doesn't matter which side the variable is on. You're just trying to get it by itself on that side. So if it's over on the right here, that doesn't make any difference. Don't worry about that. It's being multiplied by negative 7.3, so I divide by negative 7.3. That gets x by itself. Positive divided by negative is negative. I'll bring this division over here. This is an example of some of the work we should be showing. I'm not bothering to worry about signs here when I'm pulling my division because I already accounted for my sign. Right? I know it's a positive divided by a negative. I know the answer is going to be negative. I don't need to worry about the sign beyond that. So when I do my division, again, I have a decimal here, so I have to move the decimal over 1. So 73 does not go into 58. It does go into 584. So thinking about how many times I might need to do some trial and error. I think about 7 into 58. I know 7 times 8 is 56, which is pretty close. So I'm going to try times 8. Okay. 3 times 8 is 24. Carry the 2. Look at that, 584 exactly. Okay. So it goes in 8 times with nothing left over. Okay. And because I moved the decimal over 1, it's right after the 8, so it's a whole 8. Okay, so negative 8 is my answer. Okay. All right. One more here. Do my train tracks. Here's one where we have division happening. All right. The variable is being divided by a negative 9.2. To undo that, I got to multiply by negative 9.2. That cancels out. All right. So when I'm multiplying these, it's a negative times a negative, which is going to be positive. 9.2 times 3, 6, 27. Replacing the decimal, I know I have one number after the decimal point, so it's got to be the same in the answer. So m equals 27.6. Okay, thinking if that makes sense. If I replace m with 27.6, Well, I know 27 is 3 times bigger than 9. So I should get something around 3, and it's a positive divided by negative, so it should be negative. So that makes sense as an answer. All right, that's all I got for you. So keep practicing that process. Keep making sure you're drawing your train tracks, thinking about what's happening to the variable and what the opposite operation is. Okay, that's what's going to really help you out as these get more and more complicated. All right, good luck.